Welcome to episode 42 of FTCE Seminar, a teacher certification podcast. I'm your host, Mercedes Musto. Today, we will be having a math conversation to help you prepare for the FTCE General Knowledge Mathematics subtest. And today we're going to explore how to determine appropriate units of measure. And for extra fun, we're going to talk a bit about scientific notation. So get out your rulers, your graduated cylinders, and your scales, because today we measure. Oh, wait. No, we're just going to discuss measurement. So factually, you don't need your ruler? Yeah. Alrighty, well, I just got really excited, so let's get started. Concept number 1, measurement units. To begin with, let's understand the importance of selecting the right measurement unit. Imagine you're tasked with measuring the height of a skyscraper. Immediately I think, well, height. Is that like how tall is this skyscraper? And I'm 5 feet 2 inches tall, so maybe I would measure a skyscraper using feet? Let's explore units of length, like yards, feet, meters, centimeters, or maybe even millimeters. Yeah, I could use millimeters, but maybe that would give me an unnecessarily large number. So, when you put it that way, measuring a skyscraper by meters or feet seems like more suitable, practical, and precise. Now, back to our height example. Let's discuss how to determine the appropriate measurement unit and form for length. If you're measuring the height of a person, centimeters or inches might be suitable if they're really small. However, if you're measuring the distance between two cities, kilometers or miles would be more appropriate. Here's the key. Also consider the scale of the object or distance you're measuring and choose a unit that provides a balance between precision and manageability. Moving on to area, let's consider real-world scenarios, like calculating the size of a piece of land for construction purposes. Remember now, the key is scale. Here you would measure in square meters or acres. For smaller areas, square feet might be more suitable. Remember, the unit you choose should reflect the size of the area being measured while being practical and precise. One more thing, let's talk about volume. Picture yourself filling a swimming pool. Liters or gallons would be appropriate units for measuring the volume of water. Conversely, if you're measuring the volume of a tiny droplet, milliliters or fluid ounces might work better. Again, consider the scale of what you're measuring and determine the most appropriate unit of measurement. Lastly, let's discuss mass. We use grams or kilograms to measure mass. For objects with larger mass, kilograms or pounds would be used, as in, how many kilograms is that refrigerator before I attempt to move it? However, what about objects of smaller mass? How do we measure those? Well, I'm glad you asked. When measuring the mass of a tiny little object like a paper clip, grams or ounces would be much more appropriate. Again, think scale of an object before selecting the unit of measurement. Pop quiz, now that we've talked a little bit about length, volume, and mass, how would you measure the distance from the sun to the planet Earth? Whoa, yeah, right, because that's like a lot of length, right? And if I use kilometers, then that would be a really big number. Okay, good point. I see. What to do. Here's where I would apply the concept of scientific notation. See, the distance from the sun to the earth is approximately 150 million kilometers. That's right, 150 million kilometers. That's a lot of zeros. Therefore, in situations where we have extremely large or small numbers, we can use scientific notation. But what is scientific notation? Scientific notation is a method of expressing very, very large or very, very small numbers. And a lot of times these very large and small numbers are inconvenient, or unmanageable in regular decimal form like 150 million kilometers. So basically, using scientific notation makes this process more manageable. How would the distance from the sun to the earth look like in scientific notation? Okay, well, Earth is 150 kilometers. That's a lot of zeros. But when we apply scientific notation, it is something like, let me think here, 1.5 times 10 to the 8th power in kilometers. Okay, I kind of had to think that through. So, how would you convert 150 million into the scientific notation that's 1.5 times 10 to the 8th? Well, that's a great question, and I'm glad you asked. To convert the number 150 million into scientific notation, you would first identify the decimal point in the number. Where is that? In this case, the decimal point is at the end of the number, so it's 150 million decimal point, and then it would be 0000 because there's nothing after this whole number. Next, rewrite the number in scientific notation format, which means rewriting the number between 1 and 10 multiplied by the power of 10. Okay, stay with me now. For example, move the decimal point in the original number 150 million to create that new number between 1 and 10. What does this look like? This new number is 1.5. We'll get there. Now, I know I said I counted the number of places that I moved the decimal point. In our example, we moved the decimal 8 times to the left. This count represents the exponent of 10 in scientific notation. For more on exponents, check out episode 40. One more time. Let's put this all together now. Here's how I converted 150 million into scientific notation. First, move the decimal point in 150 million, that's 150,000,000 decimal point, to create a number between 1 and 10. In this case, you will move the decimal 8 places to the left, yielding 1.5. The number 1.5 is between 1 and 10, so it's in the correct format for scientific notation. Next step. Since you moved the decimal point 8 places to the left, the exponent of 10 is 8. Therefore, 150 million in scientific notation is 1.5 times 10 to the 8th power, or 10 to the 8 for short. Wait, that all makes perfect sense now. Yeah, I told you, you got this. Let's review. Determining the appropriate measurement unit and form for real-world problems involves considering the scale of an object or distance being measured, whether it's length, area, volume, or mass. Selecting the right unit and form is essential for precision and practicality. Next, in situations where we have extremely large numbers or really, really small numbers, we can use scientific notation because scientific notation makes very large and very small numbers much more manageable. For more practice with math, visit FTCEseminar.com to study for the test. The important thing is to start studying today so you can pass the teacher certification exam. Well, hey, what are you waiting for? Check us out on YouTube at FTCE Seminar and start studying today. This podcast was recorded at the Pickens Multimedia Studio at the University of West Florida. This podcast is listener supported. Contributions can be made via the listener support link on Spotify, or hey, you can buy me a coffee at FTCEseminar.com. This is your host, Mercedes Musto. Join me again on FTCE Seminar, a teacher certification podcast, so you can pass the FTCE.